You know, solar energy is one of the fastest growing power sources on the entire planet. We're seeing these huge shimmering solar farms out in the desert, and panels are just popping up on rooftops everywhere you look. It really feels like the future is here, right?
But that leads to a really interesting question. I mean, if solar is the future and its costs are dropping like a rock, why does it feel like large-scale adoption is kind of hitting a wall? What are the real hurdles that are standing in the way of a full-on solar revolution?
All right, so let's get into it. While a ton of investment is pouring into solar, the path to a fully solar-powered world, well, it isn't just about making more panels. It's actually this super complex puzzle that involves policy, finance, and the electrical grid we already have. So, let's tackle that first piece of the puzzle, the big policy and financial hurdles. You could call these the soft barriers. They're the man-made obstacles that can be just as tough to get around as any engineering problem.
And what's really fascinating is how all these risks are totally connected. I mean, put yourself in a developer's shoes for a second. If the government's policies are always changing, it creates this huge cloud of uncertainty. And that uncertainty, combined with painfully slow approvals, makes getting affordable financing almost impossible. You can see how even a great project could just get stuck for years.
And this just shows you how long that road really is. It's not just one step and you're done. No way. You've got the initial proposal, then these massive environmental surveys, public hearings, and these super complex studies just to see if your project can even hook up to the grid. Any single one of these stages can cause massive delays, adding years and millions of dollars to the cost.
Okay, so even if you somehow manage to get through that whole policy maze, you immediately run into the next big set of challenges: the physical limits of our power grid and our ability to actually store all that energy. So, the key word here is intermittency. It's a pretty simple idea, but it has some huge implications. The sun doesn't shine at night, and sometimes it's cloudy. It means solar power just isn't available 24/7, and that is a fundamental problem for a grid that needs constant, reliable power all the time.
Which, of course, leads to the million-dollar question, or maybe it's a trillion-dollar question at this point. How do we power everything at night or on a rainy day if we're all in on solar? How do we possibly bridge that gap?
Well, the answer is energy storage. We're talking about massive batteries that can soak up all that solar power during the day and then release it at night. But here's the bottleneck. The technology is there, but the cost of building enough battery storage to power whole cities is still just incredibly high. It's one of the single biggest roadblocks we face. And this whole problem is made worse by the grid itself. You know, most of our electrical grids are based on a design that's like 100 years old. They were built for a few big power plants to push electricity out in one direction. They were never, ever designed for a world where millions of homes and solar farms are pushing power back into the grid. So upgrading to a modern, flexible smart grid is this enormous but absolutely necessary undertaking. All right, next up, let's get down to the most basic challenges of all: the limits on actual physical materials, manufacturing, and, the land itself. Because even if you've got the policies and the grid all sorted out, you still have to actually build the thing. And that means dealing with global supply chains for parts, which we've all seen can be disrupted pretty easily. It also means getting your hands on these huge areas of land for big projects, which involves tricky negotiations and super long environmental reviews. It's a total logistical gauntlet. So after hearing about all those challenges, you might be feeling a little down on the whole thing. But the story absolutely does not end there. Let's pivot now and look at how innovation is actually clearing a path forward and tackling these barriers head-on.
First up is policy innovation. More and more, governments are figuring out that stable, long-term policies are absolutely essential. They create a predictable environment where investors and developers actually feel confident enough to commit the billions of dollars needed for these massive solar projects.
And next we have those smarter grids. That transition is already happening. Utilities are pouring money into upgrading their infrastructure, adding sensors, and using new software to better manage that two-way flow of energy from sources like solar. It's a slow process for sure, but it is happening. And finally, we're back to storage. Thanks in large part to the electric vehicle boom and some incredible research, battery costs are falling, and they're falling fast. As that trend continues, large-scale energy storage is becoming a real, economically smart option. And that directly solves that core intermittency problem we talked about. So if there's one thing to take away from all this, it's this: overcoming these big industry-level barriers is the absolute key. It's not about finding one magic bullet. It's about systematically solving all of these interconnected problems together. That is how we unlock a clean, secure, and sustainable energy future. Which really leaves us with one last thing to think about. The solutions are definitely starting to emerge, and the momentum for solar is huge.
So, what do you think? What will be that final tipping point that takes us from just steady growth to a truly global solar-powered world? Thanks for tuning in.